This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at reactroundup.com/KendoUI.
Welcome to React Roundup this week. We have Tanmai Gopal from Hasura, and I'm your host, Sia Karamalagos, and I live in New Orleans. And we also have Nader Dabbit as our other host.
Hello, from Mississippi today.
Hi, this is Tanmai. I'm in San Francisco.
So Tanmai, tell us more about yourself and Hasura.
I'm the founder at Hasura. We've been building this GraphQL tooling to accelerate being able to use GraphQL for app developers. I have actually been building applications for about a decade now on a variety of stacks. I think over the last few years, especially, my focus has been on functional programming functional programming practices, and also on the cloud side of things, on Kubernetes and Docker. And so there's a lot of work that I do and that we do at Hasura in the Kubernetes and Docker space. I think my journey with React started also pretty early. I think like a few years ago, around the time it was just becoming popular. And I think one of those big moments was I'm one of those people who was, I think, using React when Flux was around. So I don't remember if you know a library called Flumux. So I used to use Flux and Flumux, and it was a nightmare. And at the time, there's something called Elm that came out, and Elm was amazing because most of our backend stuff is in Haskell. And then we looked at Elm, and it was so exciting. And then we were like, oh, but it's not Haskell. We can't use Elm. I don't know if it'll play along well with JavaScript libraries. It does, but you had that kind of hesitation. And then Dan Abramov kind of like dropped the bomb with Redux, and then I think that's when we kind of got into React proper. And then we kind of moved everything that we had in the front end to React plus Redux. There and many years in that ecosystem. And then today, here we are with doing some GraphQL stuff as well.
So how long has Hasura been around?
I think we've been we're just about to finish a year as Hasura, as a technology, but quite a few members of the Hasura team as it is today. We've been working together for a while on different technologies. We used to work together on a company before this as well, where we were building products for people, doing consulting for enterprises, helping them move their monoliths to microservices, stuff like that.
What inspired you to start Hasura?
Well, honestly, it was just like we were building things and we were helping other people build things, and then we realized this can be easier. Why is this so painful? And when we said that this can be easier, there were kind of a few pieces of technology that we were building out. And I think the most exciting piece, or the piece that has the most amount of value, is to say, what if we can remove that layer in the middle where you kind of have to write this irritating backend code, which is doing nothing but really just talking to the database and making the database more accessible for application developers. What if we can automate like that process? Because you can't really take the database away, right? Like, the business is in the database. Like, the database is something that will make or break your application. That will be the bottleneck eventually. So you have to manage the database, or you have to outsource the management of the database. And you also have to build the app, which is, your front end and your business. That's your application. That users see your product or your business. But this piece in the middle, that just seems irritating, like, most of the times. Like, there is necessity, but there's also like a little bit of irritation and kind of like just setting up that access to the database kind of work that needs to be done. And so that's where we kind of built this piece that says, hey, you know what, you get instant GraphQL on Postgres, and it's super high performance. And we take a very different approach to doing this, but that's kind of the genesis of how this started, and that's how this GraphQL piece on Postgres came to be. So,
can you kind of give the elevator pitch of Hasura? I know you mentioned quite a bit Absolutely. About it already, but if you were just to meet someone and they were interested in it and you wanted to kind of give them the quick spiel about it, can you kind of like go over that before we go in too deep?
Okay, absolutely. So Hasura gives you instant GraphQL APIs for your apps on top of a Postgres database. So it can be an existing Postgres database, or it can be a new application that you're building, and you get to use GraphQL from your apps directly.
So do you offer like a database as a service, or is this just more of like a layer and then they choose wherever they own their own database, whether it be like in a cloud service provider or maybe even locally or something like that?
Well, both. So the data layer that we're going to open source soon is going to be just a GraphQL data layer that you can add in front of your database, wherever it is, on your cloud or on-prem, or kind of wherever you have your managed database. But we also have a cloud version, which is a hosted offering, which comes with the GraphQL layer and Postgres, both of which are managed for you.
So does this basically look at your Postgres like SQL schema and then build the GraphQL schema and endpoints based on that?
Exactly. That's kind of exactly what it does. The conceptually, yes. The approach is a little different. What it does is it kind of looks at your existing Postgres schema, and then you as a developer can say, hey, you know what? These are the tables and these are the views in my database that I would like exposed over GraphQL. And then as soon as you specify that metadata, this layer is now aware of this layer now kind of constructs that schema and provides that schema to applications. And then when a GraphQL query comes in, this layer compiles that GraphQL query into the right SQL and then kind of executes that SQL query on the database. So it's a little different from resolvers and kind of writing resolvers for a nested kind of a GraphQL query, where you have nodes and then you have a nested node and then you're kind of making a query. Instead of that, what it does is it takes the entire GraphQL AST, converts that to an SQL AST, and then actually just runs the SQL against the database. It's kind of what you would have done by hand, right?
If you wrote your own resolvers.
Yeah, exactly.
Very cool.
I think one of the it's slightly different from writing your own resolvers. I think it's kind of more similar to saying that let's say, for example, you had a GraphQL query and you were making a GraphQL query for fetching the profile and for a user profile, and within that user profile, maybe the user had the 10 different addresses, right? So I have 10 different addresses because I'm a globetrotter and I live in SF and Paris and Bangalore and wherever, London. And then if you have that kind of a profile where you have this graph, right? What you would do typically is you would write a resolver for the profile node and the resolver for the addresses node as well. Whereas actually what's happening is that in the database, you just have the profile table and the addresses table, which are kind of linked together by, say, a column or by two columns or whatever, right? And that's already there in your database. So what Hasura does is it kind of looks at that GraphQL query and then just compiles that into like the right joined query. So it's different from writing a resolver, because what happens with a resolver is that you end up processing like the top level node and then like the node that is one below it as well. And then you run into what is called the n+1 query problem. And you have to use something like data loader to kind of cache that or prevent repeated access to the database, which you would not have had to do if you had written an SQL query that would have fetched from both of the tables simultaneously in the same query, right? And if you could have done that, then you would have avoided that. Then you would have written that one SQL query. So that's kind of what Hasura is doing. In a sense, it's exactly like what apps do to a backend API, right? Like you say that, instead of using a REST API, use a GraphQL API to query all of the data in one shot. That's exactly what Hasura does to Postgres and says, hey, instead of like requesting for the different pieces of data from the database, let me just make one SQL query to fetch all of the data in one shot.
Okay, so it's like the API to the to like your user interface or wherever you're trying to request data from. You're writing GraphQL queries, but it's written in such a way so that instead of using traditional resolvers, it's just you're building an efficient SQL query to get everything in one query. And so I guess caching then is on the database for those queries.
Exactly. And it's very interesting, especially because when we come more from like the backend side, and when we're doing this and when we were working with GraphQL over the last year, it's so interesting to see similar patterns and ideas that were there in the database community also kind of coming in on the GraphQL community, right? So for example, the idea of query variables in GraphQL. So where you have persisted queries and query variables in GraphQL, right? So for example, what Facebook does is when you have a Facebook application, the Facebook app is making a request to the Facebook backend. The GraphQL queries, you don't actually send the entire GraphQL query. You actually just send a query ID or a query hash, and along with that, the query variables that are important for that query, right? Mm-hmm. And so you're kind of minimizing the data that you're sending to the GraphQL backend as much as possible. And so you're just sending the query ID and you're sending the query variables. And now the backend already knows what to do with this query or knows what this query ID refers to, and then executes the right GraphQL query. And databases have been doing exactly that. So databases like Postgres have been doing exactly that. So Postgres has something called prepared statements, which lets you take an SQL query and say that, hey, this is my SQL query, but there are portions in this SQL query which are variables. And so those are called prepared statements in Postgres and prepared statement variables in Postgres. And that kind of makes your query execution super fast because the database already has this query cached. It can even efficiently cache the results of this query if this query is being repeated often. And so if you think about it, it's super nice because now from the app, you're making this query where literally the only thing that you send from your application is the query ID, the 4 variables that you need to fetch something from the query. And it kind of just zooms straight into the database. You did the right kind of access control and stuff that's built in to make sure that you don't actually just have raw access to the database. And the database also has everything cached right up to the variables. And then you just extract that piece of data out and then send that back to the client.
So it's a bit like a GraphQL like ORM in a way.
It's kind of like a GraphQL ORM, but it's like the way we intended this to be was to be more like a GraphQL ORM for apps, right? Mm-hmm. It's more like a GraphQL ORM for apps. But speaking of ORMs, you're right. You could also use this as, let's say you're writing serverless functions in Lambda, or you're writing different microservices, and these different microservices need to kind of talk to the database. And you don't want to. There are multiple problems when you're talking to a database, right? I think the top 2 problems that I've faced in the applications that I've worked on are, one is that you need to kind of manage. You need to be aware of the database. You need to be aware of the database schema. You need to be aware of how to access the database and stuff like that. And so you need this connection pool that you need to have with the database, right? Because databases don't give you HTTP connections that you can switch off and on quickly. Databases give you persistent connections, which are long-lived connections, so that your data interaction with them is more efficient. So that means that every microservice that I write actually needs to have a connection pool with the database. And so this makes the scalability of my microservice harder. So which is why, if you notice, you'll see that when you look at AWS Lambda and you're writing serverless code, right, that needs to talk to the database, you won't see too many examples of people trying to use serverless functions that are directly accessing an RDS database. Because what if I have 10,000 functions that suddenly get spawned because of 10,000 events that came into my system or 10,000 API calls that happened? You can't have 10,000 connections to the database. You can only have 100 connections to the database. And this is kind of the problem with databases in these modern kind of applications today. And if you front that with GraphQL, and especially the kind of GraphQL layer that Hasura gives you, you now have the ability to talk to your RDS almost with the full power of just raw SQL. But you don't have to run into these problems because that GraphQL layer, which is scalable, is given to you by Hasura. So you don't have to worry about, hey, I have a connection pool with RDS, or how do I need to manage that, or the access the way I manage access to my RDS database. That kind of goes into this neat GraphQL ORM layer that you have on top. So
how does authorization work, and how is that handled?
Yeah, that's a super interesting question. So I think there are many different approaches to doing this. I think if you take a look at the community today, I think the 3 tools that give you GraphQL on Postgres are, so you have PostGraphile, you have Hasura, and then you have Prisma. And I think all of these 3 tools are on a very interesting spectrum of different use cases. So on one side, you have PostGraphile, and what PostGraphile says is, when we're going to do authorization we're going to give you a GraphQL layer on Postgres. PostGraphile uses, so the database itself, which is Postgres, comes with a user and a role system. So Postgres itself has the notion of users and roles, and you can create a Postgres role that has row level access or field level access to certain elements. So I'll just take a simple example. If you have a profile table, you can say that, hey, I have Postgres users, and each Postgres user is allowed to access particular tables, allowed to access the profile table only where the user ID is equal to the user ID that I see in the Postgres user system, right? So that is one approach, and PostGraphile is on that side, or that kind of an approach. On the other end is Prisma, which says, hey, this is exclusively a GraphQL ORM. You can't actually make queries to Postgres directly from your front-end apps. Your app makes a query to your GraphQL backend. Your GraphQL backend makes a GraphQL query to Prisma. Prisma makes that query to Postgres, right? So that way, the authorization is done in code, in your GraphQL backend code that you write. Hasura is somewhere in the middle. And what we do is we kind of give you a metadata layer that sits at the GraphQL engine. So what you essentially do is as an application, you make a request to the Hasura GraphQL engine. Hasura basically takes whatever you sent in the request. Let's say you sent a token. Let's say you sent a cookie. Whatever you sent as headers or as credentials to Hasura. Hasura will take those credentials and ask a webhook that you provide to convert those credentials into what are called principals. So, for example, you can say user ID, role ID, organization ID, app ID, right? So you have to return these kind of variables. And now these variables can be used to specify access control rules that are automatically injected in the SQL query that you execute on the database. So let me just kind of step back a bit. It was a very long sentence. But if I step back a bit, basically the way this works is I'm a user. I want to access my profile information. I should only be able to see my profile data. So I make a query to Hasura GraphQL engine with my token. My token goes to your webhook that you write, and the webhook says user ID equal to 2. If I make a GraphQL query that says fetch all the profile data, what this extra rule you can specify an extra rule for the profile node that says if the profile data is fetched, user ID must be equal to profile.user ID. And now this rule will get injected in that SQL query, which is made to the database automatically. So that's kind of the access control rule that happens there. And then when I finally get the response, I'm only seeing the response for my user ID. Except it's not just user ID, it's as dynamic as you want it to be. So if it's a multi-tenant kind of SaaS application, it would be organization ID, right? If I'm the admin of my organization, I can see my entire organization's data. So it will be X org ID. It will be like an org ID instead of just a user ID. Does that make sense?
Yeah, it does make sense. It's interesting that I haven't really used Hasura, so I'm not familiar with some of the techniques you're talking about, but they make a lot of sense. I'm curious, you mentioned, I guess, a couple of other, I guess, options or services that are in the same space.
Right.
What would you consider like a competitor to kind of what Hasura is doing in general?
I think both PostGraphile and Prisma fall in a similar space. So we're all kind of in the same space, and it's a fairly nascent space. So I think everybody's offerings are going to evolve as the market kind of uses these products and says, hey, I want more of these features, or I don't want more of these features. But I think we're all in the same competitive space. I think Hasura's key difference is that it's focused more on helping you work with existing databases as quickly as possible. Whereas I think Prisma and PostGraphile are more suited for new databases. Well, PostGraphile can still be used with existing databases a little bit, but Prisma is especially suited only for new databases. Like I have an empty, like I own the database. It's my database on my Amazon, but there's no data in it. I don't have a legacy application on it. Whereas Hasura is very squarely focused on making sure that you can get productive on an existing legacy application that is already using Postgres as well. So I think, but I think we're all in the same space. So I'm sure everybody will start like learning from each other and doing similar things.
Deploy more, pay less with DigitalOcean, the simplest all-in-one cloud computing platform for developers. Scale and run cloud applications faster and more efficiently with effortless administration tools to robust compute, flexible configurations, networking services, real-time alerts, and rapid provisioning, while enjoying industry-leading price to performance with a flat pricing structure across all global data center regions at any usage volume. Spend more time building better web apps and less time worrying about managing infrastructure with DigitalOcean. Build your next app on DigitalOcean. Get started with a free $100 credit at do.co/roundup.
So in this setup, if you needed to access data from other sources as well besides your Postgres database, like external APIs or whatnot, how would you recommend architecting that?
I think I think that's the short and simple answer is schema stitching. And so, are you aware of? So, schema stitching is this idea where you say, I have multiple GraphQL services that I use on the back end. So, let's say, for example, I have GraphQL microservice 1. I'm using Algolia, or I'm using some shipping API, or I'm using a bunch of other third-party APIs, and now I'm using GitHub's API, right? And all of these different APIs are also GraphQL services. So because everybody's moving from kind of REST to GraphQL, so it's not just an external data source, which is a REST API, but it's an external data source, which is a GraphQL API. So then the kind of standard that's emerging, or what people are kind of starting to do when they reach those use cases, is that instead of directly talking to the one GraphQL microservice that you were using, which kind of was solving your problems, you then talk to a GraphQL microservice that you write, that you've handwritten. And then this GraphQL microservice can actually stitch together different data sources. So for example, one of the most common examples, or simplest examples to understand is, again, going back to the profile use case where I have ID and name and city, let's say. So I have ID, name, and city. And so it says, okay, here's Sia, and Sia is in London, and that's the query that I have, and that's in the database. But I also want to attach weather information to this profile. So this weather information definitely does not live in my database. The weather information comes from a weather API. So now I want to have a user type that has ID, name, city, and weather, right? It's not just ID, name, city. So what you can do with schema stitching, and this is tooling that Apollo's been putting out, and it's been picking up a fair bit of traction. It's a little bit complicated, I think, but it's getting easier and easier. So I think the most recent release of schema stitching is absolutely amazing to use. And what this lets you do is say, I'm going to extend that user type, and I'm going to create a schema which has user with ID, name, city, and weather. And when this query comes in, the weather portion is something that I'll resolve. I will write code to resolve that. But the rest of it, I will kind of just delegate to the other microservice that I have in the back, which is the Hasura GraphQL microservice. So all of the logic and the work that is related to your database, including authorization, access control, aggregations, views, all of that is kind of delegated to Hasura's GraphQL microservice, and everything else can be done at your schema stitching layer.
Can you talk about the workflow a little bit? So if someone gets started with Hasura, are they working within their own environment, or are they working from within some type of dashboard?
So what happens is that, let's say as soon as you want to start working with Hasura, and you basically run Hasura's GraphQL engine as a Docker container, and you can run this locally. We'll be putting out a guide where you can run this on Heroku as well. So you can just do a Heroku container push, and then you can kind of deploy this container on Heroku, which just talks to Heroku Postgres. So that's the workflow for deploying the GraphQL engine. As soon as you deploy the GraphQL engine, we give you like a database admin UI. So you can you have a CLI, so you just do Hasura space console. And as soon as you open up the console, which is like a little dashboard for your database, you can basically start managing, creating tables, creating relationships in your tables directly. And that's actually just talking to your Postgres database. And you also have a little graphical so that you can start using GraphQL and trying GraphQL out on the database that you're creating. So that's like a little, it's almost like a PHP my admin meets graphical. So that's kind of what the dashboard looks like. And you can just kind of fire that up locally.
So if someone wants to also kind of get started with Hasura, is there any specific API, specific language that they need to learn? Or is it just, do they just write GraphQL, or are there some specific syntax that kind of goes along with Hasura?
Well, I think like Hasura just gives you a GraphQL API. And so you can kind of, you can use any client library, any language to kind of connect to those GraphQL APIs. So for example, if you have JavaScript, you would, or if you're writing React, you would use something like Apollo or Oracle to connect to Hasura. If you were writing code in Python or Ruby or Java, you have different GraphQL clients that you can use to connect to the GraphQL server. So that's, So it's kind of client language agnostic.
And I guess people can use pretty much any GraphQL client to connect either Oracle or Apollo or whatever.
Correct. We don't support Relay yet because Relay has a slightly more custom spec. But yeah, we're kind of figuring out how we kind of go in that Relay direction soon, but not yet.
So the best way to learn how to use it is, I guess, to go to your website. You have docs Absolutely. On the API.
Yep. Just click on Get Started. And in fact, if you're looking at getting started super fast, then we kind of host everything for you so that you don't have to deploy Postgres and GraphQL yourself. So that's the experience that you'll see today on the website. If you just click on get started and kind of head there and then start using Hasura there.
So tell me more about your logo. Is there a story behind it?
Yeah. So Hasura in Hindi is demon. And I think we were punning on Unix daemons and FreeBSD daemons. Daemons are background processes or servers. Like servers are daemons, web servers are daemons. So daemons, DAEMONS, right? And these are like background, these are services that run in the background that kind of give you an API or talk over the network, right? And so that was a pun. And then most of our backend code that we have written our server in is Haskell. And so that's where the H comes from. And that's why there's a little lambda that we use everywhere. And so it was Hasura was born. I mean, yeah, that's the official story. The unofficial story is that a bunch of us were in a car, and one of our colleagues said, "Hey, we should have Hasura in the name. Demons are cool." And then the other colleague said, "Yeah, we can do Hasura because of Haskell," and that's it. That's really it. It was 45 seconds.
Nice.
Yeah.
So I'm kind of curious. You're betting a lot on the GraphQL technology or the specification, I guess you'd say. Do you feel like we're going to see a lot of growth in the GraphQL community over the next few years? Like, are you seeing a lot of people picking GraphQL up over REST?
Absolutely. I think it's going to be. Huge. It's going to be very game changing for several reasons. One of the things that's been very surprising to us is that we've received so much interest from enterprise folks that you don't traditionally associate with, being like on the cutting edge of technology and using the latest tools. And like architects and VPs from these enterprises are coming to us and saying, "Hey, we have, we want to use GraphQL." And so we ask them why. And I say, because we're building things that take 6 months and we want to reduce that time to 3 months. And it seems like GraphQL will help us do that, because GraphQL doesn't actually solve a technical problem. GraphQL actually solves a politics problem, right? And that's something that's very interesting to kind of to step back and take a look at, because if you think about it, what you do with GraphQL, which people think is exciting, that hey, I can query whatever data I want, and that's amazing, right? But you could have done that on not a REST API, but you could have done that on a JSON API as well, right? You could have created your own query language in JSON. If you're familiar with Mongo lets you query its data in like a JavaScript object or in JSON, right? Where you can say, I want to make a select query on this table. These are the columns that I want. This is how I want to filter it. And that entire query language actually is represented as a JavaScript object or and can be serialized to JSON, right? So there's nothing stopping you from actually implementing that kind of data efficiency that GraphQL gives you in your own language, right? But that's not what makes GraphQL an absolutely killer thing for teams that are building applications. What makes it an absolutely killer thing is that the GraphQL server says that it is mandatory for you, if you're the backend developer and I'm the front-end developer, you must build a server that not only gives me APIs, but also serves the documentation and the schema of what is a valid API call within the server itself. And this is amazing. This is amazing for me as an app developer, because now I never need to talk to you to figure out whether the documentation is right. I don't need to wait for you to create endpoints. I just take a look at the schema, and this schema represents the space of all possible queries that I can ever make with the backend. And I just go ahead and make those queries, right? So this business of you building an endpoint where you say, hey, you know what, like these are the 5 things that you have, and then these are the 3 things that these are the 5 input parameters, these are 3 output parameters. If you build your own API that is as flexible as GraphQL, you'll realize that what is missing is documentation. And then I won't have clients. I won't have client-side tooling. There will be nothing else to help me use this custom query language that you've created. So if it's REST, I don't have flexibility. If you don't do REST and you build your own query language in JSON or with query params, so there was a very interesting Hacker News thread where somebody from, I think was it Shopify or somebody else said that, hey, we do this as well. We give you the same flexibility as GraphQL does in the internal applications that we build, but you kind of specify what data you want as query parameters. So I say I want the profile, but I only want ID and name. which is similar to GraphQL saying that I only want ID and name and not the 10 other columns. So if you do this middle path of saying, I'll build my own flexible query language API endpoint, that's great from the data efficiency point of view, but really horrible from a maintainability point of view. Like, I don't know what spec that is. That's an API that you've written. Only you know how to maintain that API. If you move on from the team or that team moves on, nobody else will know how to deal with that query language. There's no client-side tooling for that query language, right? And hence, if you take that to completion, GraphQL is a spec. It's a specification for saying, here's how you build your own query language. And it's mandatory that you serve the schema of that query language as a part of your server. And as soon as, and that was incredible, and that was an incredible idea to say that the server must also serve the schema as a part of the server. And when the server starts doing that, it becomes possible for the clients to take on a lot of control. It becomes possible for the clients to validate their queries before actually running their apps. Because usually when you're building an app, it's a kind of bit of a hope and prayer, right? Like you're like, oh, okay, the documentation, I hope it's correct. Let me just make this API call. And then you never till you actually make that the documentation is correct, because these systems are just completely decoupled. But now what you can do is, and tooling, you have tooling for VS Code and you have tooling for all of your IDs, where as you write the API and as you write the API query, you'll get red underlines if you make a typo. You'll get a red underline if it says, hey, this thing is not a part of your schema. Like I mistyped user and I typed it as user A or USRE. That tooling becomes possible for clients, right? And this is game changing, right? It's really not the tech that is game changing. It's this idea of this decoupling and making the backend and front end team independent to such a degree that that communication is only necessary where the actual underlying data models change, or you're adding more features to your application that needs more data sources. Only in that case is there actual communication between the two teams. But otherwise, we're just independent teams, and we can kind of work together. We can work together without actually having to talk to each other as quickly as possible. And this is the reason why it's such a game changer. And what I've started asking people nowadays, and I don't have enough data to actually understand this, is that I ask people, and I say, let's say you have all of your REST APIs, and let's say you just convert them to GraphQL. You don't even do the graph portion of it. You just convert it to GraphQL. Like every REST endpoint is one GraphQL query, right? It's not even smart. It doesn't actually do it doesn't link different pieces of data together, but it just gives you documentation. Would you do this? Because this is something that you can do in 10 minutes. This is automated tooling for doing that, for converting your REST APIs to GraphQL. Would you add this to your backend project just so that your front-end developers don't need documentation anymore, right? And I think, and my gut feeling is that people will kind of start doing that. I mean, you never know, but I think people will kind of start moving into that direction because this solves a very real problem, right?
So are you seeing front-end developers kind of take over another form of development that they haven't in the past, where they kind of go one level up the stack in a GraphQL environment, where they're actually appending and updating and manipulating the schema and resolvers in order to get more functionality from their APIs? And is that kind of something that you're seeing, or is that not actually happening? It's just a kind of a general question.
I think you don't even need to look at GraphQL to understand the trend, right? I think if you step back and look at Parse and Firebase, and the rise of why these tools became so popular with developers, it's because developers wanted to move upstack, right? It's because developers wanted to be able to say, hey, I need to specify what I want to read and write on the backend, and I just want control of being able to do that in a way that's performant and secure and whatnot, right? And those are kind of the precursors to this. And now you have like GraphQL backend as a service like Hasura or GraphQL or Scaffold or AppSync, which kind of give front-end developers that same experience. So there is definitely this trend for application developers to take on more control. And that has seen a lot of tooling on the kind of like the startup or the, I'm prototyping an app quickly to see or to validate this idea at that stage. But when you look at it from the other end, which is like people who already have like legacy applications or have large teams, and they're like building complicated applications for like businesses that have millions of users, right? In those cases, it's a little harder to hand this control off. It's not easy. It's not easy to give control to the front end developers to say, sure, just go in and build whatever schema you want. and we'll let you query that. Right? That it's not easy because of a control and security problem, which you need to really worry about when you're handling like information from millions of users, and a performance problem, which is that you need to the application developer might end up doing something that works for the demo and the dev and QA, but then just suddenly fails massively on prod, right? So that's the reason why it kind of doesn't happen, amongst other reasons. That's one of the big reasons why it doesn't happen and why you don't hand off that much control. But that said, there is an increasing desire to give control to the application developer in a way that is easy to handle. And I had a very interesting conversation with the developers at Twitter, who were very proud of the fact that now if you go to your Twitter profile and you click on your profile, and I think you can switch notifications off and on, or there's a toggle feature on that profile button, right? And the development experience for that one feature was entirely front-end application developer led. There was no back-end code that was written for doing that. So it went through the process and the checks and balances, but the writing of the code and the specification of how it had to be done could kind of be done only by the application developers. So the trend is there, but I think the tooling and the process is still evolving to kind of validate that trend.
So I think you're spot on with that that description you just gave. That's kind of the same thing that I've been seeing a lot of. I think what we're seeing is how serverless kind of revolutionized how a lot of back-end development was done and processes, and kind of helped, I guess, make more efficient the back-end development processes, I guess. And even some of the, I guess, way that a lot of the teams have been organized have been changed because of the serverless movement. I think what we're seeing next is going to be one level up from that into tools like Hasura and like you mentioned, AppSync and these types of things like Firebase and so on and so forth, where we no longer have to, as front-end developers, spend a day or a week or a month even waiting for tickets to go through our back end for new endpoints. This is that's where I see the revolution happening. That's kind of why I see this such a big deal.
Exactly, and it's going to be crazy, right? I think, and it's actually amazing because it's exactly like you said. Like if you look at back-end work, which is getting simplified with the serverless movement, and with things like so on the ops side, there's Kubernetes that's making stuff easier. On the back-end developer side, there's stuff like serverless that's making it easier. And on the front-end side, you have GraphQL that's making this easier. And we're kind of entering this golden age of development where you're maybe going to get to a place where it's going to be possible for one developer to build an application that will scale to millions of users within a few weeks, right? And that kind of power, I think, for existing applications and for new applications is going to be revolutionary.
So is there anything else that you wanted to kind of go over that we haven't really discussed before we start wrapping up and getting to picks?
No, I think this kind of is a good overview. I think like you folks mentioned, I think the podcast will actually go out a little later, but we're going to be releasing this as an open source thing that you can deploy on your own infra, which is going to be super exciting for us, and that should happen June 3rd week. So yeah.
Well, cool. So why don't we go ahead and do our picks then?
Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says "Pay me now." And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter DevChat in the How Did You Hear About Us section.
I guess I'll talk about mine. This week, I am playing with Gatsby JS. I don't know why I've never played with it before. So I'm rebuilding our company website on it. It's fun. It's a little black boxy. I'm not used to that. I'm used to being able to fiddle with all the things. But yeah, it's nice to get all that performance out of the box.
Yeah.
Oh, and if you don't know, it's a static site generator for React. But yeah, sorry, go ahead.
I'm sorry. I was asking, are you using Gatsby V2 or is it V1? Is Gatsby V2 out?
I don't know. I think it is V1.
Oh, okay, cool. Gatsby V2 is supposed to be even faster.
Yeah.
Yeah.
Nader, what's your pick for the week?
So my pick is the workshop that we'll be giving at the React Native EU conference in Poland in September. It's building cloud-enabled React Native applications with AWS Amplify. And we're going to be basically demoing how to build React Native like serverless apps using things like GraphQL that we just talked about, but also conversational bots, authorization, S3 storage, just a lot of different things that you normally need around a application. So the tooling we'll be using is AWS Amplify, and we're looking forward to that. Also, the React Native EU conference in general in Poland, even if you're not located in Europe or Middle East or Asia, if you're in the United States, it's a really cool conference because Poland is really an inexpensive place to go visit, and there's a lot of history around there. I'm hoping to visit some World War II stuff this year. So I hope that you're interested or if you're interested in going, I hope that you check it out and come out and hang out with us over there.
Tanmai, do you have any picks for the week?
Well, I've been working with embedding graphical in Sphinx. So Sphinx is a documentation generator. So you can generate documentation for whatever tool you're building or whatever you're writing. And if the tool that you're building uses GraphQL, it's nice to have like an embeddable graphical API explorer inside your documentation. And so I'm kind of working on building this tool that will let you embed graphical inside your Sphinx docs. Cool.
Well, I think that's a wrap on React Roundup this week. I want to thank our guest, Tanmai Gopal from Hasura, for joining us. And I also want to thank you for listening. So be sure to check us out next week too. Bye, everyone.
Bye. Bye-bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.